Alright, this video is more algebra review for calculus. And if you're watching this, I'm assuming that you are either about to take calculus or you're taking calculus right now and you need to review some algebra. So let's take a look at some of the algebra that shows up in calculus. Oops, that was... some of the algebra that shows up in calculus. And a lot of it involves simplifying. So we'll do some practice simplifying. Let's look at an example. Let's look at rationalizing the numerator or denominator. So the key idea is if you have, this is just a miscellaneous video. So let's look at rationalizing the numerator and denominator. So suppose that you had something like the square root of x plus 4 minus 2 all over x. Okay. And you're asked to rationalize the numerator. Rationalize just means multiply and divide by the conjugate so that you get something without square roots. So in this case, you want to modify this expression so that you don't get the square root in the numerator. And the key fact we'll need is the difference of squares. So the key fact is difference of squares, which says that if you have a plus b times a minus b, this is equal to a squared minus b squared. And let's make sure we know why this is true, because a plus b times a minus b I use the distributive property. Right? This is a times a minus b plus b times a minus b, because I'm using the distributive property here. And now if I distribute, then I get a times a is a squared, and then a minus b is, a times minus b is minus ab, and then I have a plus ba, and then I have a minus b squared. And minus ab plus ab is 0, right? So I get a squared minus b squared. That's one way to do it. Or another way to do it, if you want, you can also distribute. So I'm showing out the distributive property steps, but another way of doing it is to multiply things out like that, and then you get that it's a squared minus b squared. Anyway, so applying this to the square roots, if you have something like the square root of, I don't want to use a and b again. Let's say I have the square root of c plus the square root of d. All right, let's say I have that. And then I multiply by the square root of c minus square root of d. Well, if I do that, so this is like my square root of c is like my a, that's like my b, right? So I have a plus b times a minus b. And when I do this, I'm going to get a squared, that's c, and then minus b squared, that's d. So notice that by doing that, I now have something that doesn't have any square roots in it. Okay, so going back to the original problem, maybe I'll box it and move it down here. There we go. Example. we multiply and divide by, so multiply and divide by what's called the conjugate, or the radical conjugate. So what's that? So the radical conjugate of the square root of c plus the square root of d is the square root of c minus the square root of d, and vice versa. Okay, so these two are called radical conjugates. So going back to this example, if you have, I have this, and now I'll multiply and divide by the radical conjugate. Right, so this expression is equal to that. Now what's this? I need to distribute, and I have a difference of squares on the top, right? Because I have this times that. Now if you want, you can put parentheses. Yeah, it's fine to put parentheses just if it helps you with doing this. So I have an a minus b times a plus b on the top. Now on the bottom, I don't have that, and generally you want to not distribute the x across. You don't need to distribute the x across, and oftentimes it's better to just leave it to leave it like this instead of distributing the x across. But you do need to distribute the top part. So you have a difference of squares, so it's my a is the square root of x plus 4, right? And my b is 2. And if you use the difference of squares, you're going to get x plus 4 minus 2 squared. And this is equal to, well, 2 squared is 4, and I have a 4 minus 4 on the top. Now I wish there was a way to, if I do this, will it, no. To show the pointer, because that would be really helpful. I don't know why it's, really, there's no way to. Okay, what if I did this? No, that's not good. Oh, jeez. Okay, well, anyway, I'll figure this out later. But anyway, you have a 4 here and a minus 4 there, right? So 4 minus 4 makes 0. And so on the top, I just have x over x times parentheses square root of x plus 4 plus 2. And now you see the benefit of having the x out, because now I can cancel the x on the top and bottom. So this is equal to 1 over the square root of x plus 4 plus 2. And now I just want to remind you, just in case you're not sure, that these two are the same, because when I take the bottom and I multiply the top and bottom by x, I get this. I get the thing above, right? These are the same as long as x is not equal to 0. Now how come you need x to not equal to 0? Well, if you look at the top, so when you have an expression, right, and you're talking about whether the expression is defined as a specific value, you have to work with the expression as it is. I mean, this expression is not defined. Okay, this is undefined at x equals 0. Okay, and this is defined at x equals 0. Right? So, so that's the difference. I mean, they're not the same if x is equal to 0. But if x is not equal to 0, they're equal. So there, we rationalized the numerator. And there are also examples of rationalizing the denominator. Let's just do a quick example, if I can find one. Okay, so let's say that you had 1 over the square root of x minus the square root of y. So to rationalize, and we're trying to rationalize the denominator, right? Because it's the denominator that has the square roots. Well, we multiply and divide by the conjugate. So you have this, and then you multiply and divide by that. And now you distribute. And again, you don't have to, but you know, if you want, you can do this. So this expression is equal to that, and this is equal to, so on the top I have the square root of x plus the square root of y. On the bottom, I have a difference of squares again. I have x minus y. And that's done. So this is the answer. Now let's see an example of where this actually shows up in a calculus problem. So here's, okay, I have so many tabs open. Yeah, okay. So here's where it shows up in a calculus problem. So find the limit as x goes to 1 of the square root of 3x plus 1 minus the square root of 2x plus 2 all over x minus 1. So the first thing to do when you have this is you want to plug in x equals 1 into your function, into this function. And if you do that, you get 0 over 0 because you get the square root of 1 minus, wait, no. You get the square root of 4 minus 4 on the top, and then on the bottom you get 0, and then that gives you this indeterminate form 0 over 0, right? So now we know that we need to do our algebra effects. And again, we're not going to make the super basic mistake of saying that the limit doesn't exist, because the limit very well could exist. It might not exist. I mean, you never actually know if you get 0 over 0. So we're going to have to work with this function. And the trick usually is to multiply and divide by the conjugate. And if you do that, let's see what we get. Okay, so this is equal to the limit as x goes to 1 of this function times 1, of course, and then we multiply and divide by the conjugate. Okay, so you have this. And you multiply and divide by the conjugate. This smaller? Oh, I'm out of space. Okay. So this is equal to the limit as x goes to 1 of, right? Now on the bottom, that's not the part I'm really worried about. I keep things separate. I have x minus 1 and then the bottom part. This and on the top, again, I have a difference of squares. I have a 3x plus 1 and then minus. Now I see that I'm about to write a 2x plus 2. Now some students will make a mistake here. A lot of students will write 2x plus 2 like that. Now do you see the problem with that? What's the problem with that? The problem with that is that you're actually subtracting the quantity 2x plus 2. You're subtracting the whole thing. So what you need is you need parentheses around that. Because without the parentheses, what are you saying? Okay, let's say you didn't have parentheses. What this means is, right, there's order of operations. This numerator reads 3x plus 1 minus 2x plus 2. In other words, you take 3x, you add 1, you subtract 2x, and then you add 2. That's not what you want. You're trying to say that you're subtracting the quantity 2x plus 2. So you need parentheses like this in order for it to be correct. Okay, so the correct thing is to write it like this. And now we need to distribute. So now we need to simplify. So we keep everything the same except simplifying the top, and you get, well, you don't even need parentheses here. Okay. You get, so you distribute the minus 1, right? So it's 3x minus 2x, that's x. And on the top, it's 1 minus 2, because you're subtracting 2. So it's x minus 1 on the top, over x minus 1 times the quantity, root 3x plus 1 plus root 2x plus 2. And now we can, right, I have a factor, so I have an x minus 1, I'll just show this extra step, times 1. So I have a factor of x minus 1 and a factor of x minus 1 on the bottom. So when I'm multiplying and dividing by x minus 1, that's just the same as multiplying by 1, as long as x is not equal to 1. And in this case, when we're taking the limit as x goes to 1, you're looking at what happens when x is approaching 1 but not equal to 1. And so that's why we can just cancel the x minus 1s. And so you're left with the limit as x goes to 1 of 1 over square root of 3x plus 1, because we're canceling the x minus 1s. 1 over root 3x plus 1 plus root 2x plus 2. And now, when you plug in 1, you see the 0 over 0 issue went away, because it was the x minus 1 on the top and bottom that's causing the 0 to show up on the top and bottom. But now that they've canceled, you can actually plug in and substitute. Because this is a continuous function, it's substituted. So you get 1 over, we can evaluate the limit as 1 over the square root of 3 times, okay. On a test, you probably don't need to, do all of this, but I'm just showing it, you can probably just do this in your head. So you get this, and then you get equals 1 over the square root of, so you get 3 plus 1 is 4, and then you get the square root of 2 plus 2 is 4, and this is equal to 1 over, so square root of 4 is 2, so you get 2 and 2 on the bottom, so you get 1/4. And that's the limit. So that's the answer. So that's where rationalizing the numerator and denominator shows up. This is one instance. It usually shows up with limits. Okay? Now, how long has this video been? Okay, we'll do another video next time.